Hello and welcome to lesson number 4 here at Reignite Hope. And today we're going to talk a little bit about weld joint terminology, and we're going to talk a little bit about how we inspect welds. So if you got your notebook handy, why don't you pull out page 23 of your notebook, and we're going to take a look at that. Actually, excuse me, page 22 of your notebook. And we got a little bit of terminology there at the top of the page I want to go over with you. It's what we call some of the parts of a joint here on this. And so you don't need to know all the terms on there, but there are a few that are really important. So if we had a joint pretty much like this, which is what you're seeing there on page 22, this, of course, would be a butt joint. We're butting two pieces of metal together, one of our 5 joint types. We've got a groove here we're filling in, so it's a groove weld, not a fillet weld, where we're filling in a corner. And then we're going to come in here, and we're going to, of course, put a bead across the top of this and fill in all of this V groove. This is actually a V groove, we would call it. Sometimes we have a root opening here, as you see on your drawing there, and sometimes we don't. We could just butt them all the way together, but if we wanted even more strength, we'll pull them apart a little bit, create a root opening so that our weld gets all the way down in here and even comes out the bottom. So down here we've got what we call our root opening, which again may or may not be there, and it could be different dimensions. It could be a 1/16 of an inch, an 1/8 of an inch, 1/4 of an inch root opening. Up here, of course, is the top of our bead. We have 2 really important things we want to identify here, and that's called the toes of our weld. The toes. And that's where our bead is going to blend in with the base metal here on each side, and that'll become more important when we talk about how to inspect the weld. But that's the toes of the weld. This height that comes across here from the top of our bead to the top of the plate, that's just called our weld reinforcement that you see on there. I'm going to write right into my piece there, weld reinforcement. And on certain weld tests, that can only be so high. That can only be maybe an 1/8 of an inch high is the maximum the code book would allow. Any more than that would not be acceptable. The weld reinforcement there. So we've got our weld, we've got our toes, we've got our root opening, and then here we're just going to call this the groove face. On there, I think they're calling it the the groove face on there. So we have 2 faces there, our toes and our root opening. That's mostly what we want to talk about in terms of joint terminology. So now if we were going to talk about a fillet weld, we've got some of the same terminology. So if we had 2 pieces of metal here, and we brought them together to form a T-joint, another one of our 5 joint types, and now this time we're doing a fillet weld, so our bead is going to be either on this side, or maybe both sides. Again, here's the toes of our weld, right there and right there, again, where the end of the bead is welding in to the edge of the base metal there. With T-joints, we also have a little bit of an extra term here. The length from here to here is called the legs of our weld. We've got one there and one there. Those are the legs. And sometimes in your instructions on welding something, they might specify the leg length. They might say they want this bead or the leg length to be 1/4 of an inch or 1/2 an inch or 3/4 of an inch, whatever it might be. They'll specify a leg length on there. So again, our toes and our leg lengths, that's the 2 most important things we're going to concern now regarding the fillet weld. So that's some new terminology, more learning the language of welding. And so try and review that, and we'll recap it when we cover it this week in class. So now we want to talk a little bit about inspecting a weld. It's one thing to lay down a bead and create the weld, but it's another thing to inspect it. And we want to inspect every weld that we do. And sometimes there'll be actually an official inspector that'll look at your welds, but most of the time it's you. It's the welder. Most inspection is done by the welder, him or herself. So what do we look for when we're trying to determine if a weld is good? it's got to perform its job of keeping the two pieces of metal together for the amount of stress that it's going to be subjected to. So there's several things that we would consider to be weld defects and weld discontinuities, and we wanted to understand the difference between the two and what some of them are. So if you turn in your notebook to page 31, we've got a few of the weld defects listed there, 3 of them actually. On the left-hand column, you'll see something called undercutting, you'll see something called overlap, and you'll see spatter. That's 3 of the defects that we could have in a weld, and we've got a couple others that I'm going to list on the board here as well. We could have porosity, and we could have cracks. But I want to distinguish, first of all, the difference between a defect and a discontinuity. So there is no such thing really as a perfect weld. Every single weld, I don't care how good you are, could be better. There will be some sort of a discontinuity in the weld itself. So a discontinuity is some portion of the weld in which something has occurred. We either have a little bit of porosity maybe, we've got a small crack, we've got some undercut, we've got some overlap in there, and so those would be considered a discontinuity. Something has interrupted the continuity of a perfect weld, and you've got a different part going on there in your weld bead. Now, a discontinuity is not necessarily a defect. When something becomes a defect, then the weld is to be rejected. It isn't going to pass, and we have to do it over. Either go get 2 new pieces of metal, create another weld, or grind out the bad bead or the bad part of the bead and re-weld it. So a defect is a little bit different than our discontinuity. This is always going to be a reject. This might be a reject depending on how bad the discontinuity is. So for example, in the case of undercutting, which is the first thing you see there on page 31 at the top, we can have a little bit of undercutting in our welds and still be acceptable. An undercut would be something that kind of looks like this. Let's again say that we've got 2 pieces of metal here we're bringing together, a V-groove, and we've got our bead happening up here, and then right over here we've burned away this edge here and created an undercut there, and that creates a weakness. If this weld is going to fail anywhere, it's going to fail right there. We've undercut the surface or burned away the surface and didn't fill it in with the bead. Now, in some of our examinations or our codes, if that's no deeper than 1/32 of an inch, it's still okay. If it's deeper than a 1/32 of an inch, then it goes from becoming a discontinuity to becoming a defect. It is a discontinuity, period, just because it's an undercut. It could be a defect if it's deep enough. Porosity would be another example. That's a discontinuity. We're allowed some of that though. Porosity would be if we've got a bead here on a piece of metal, let's just say it's our weld bead, and then we start seeing little holes here and there in our bead, little pinholes. So we got discontinuities. We're allowed a little bit of that, but we're not allowed a lot of that, and it'll depend on the code. It might say that none of them can be larger than a 1/16 of an inch, or none of them can be larger than an 1/8 of an inch, or there can only be so many per inch, and then it becomes a defect. So if it's not real bad porosity, we could still accept the weld, but if there's enough of it there, it gets rejected and becomes a defect. Now a crack is not only a discontinuity, it is always a defect, because cracks, what do? They get bigger, right? It might be this little to start with, but just like a little crack in your windshield, over time it keeps growing and getting longer. So a crack, no matter how small, no matter how short, is always going to be a reject, always going to be considered a defect. Now overlap is another discontinuity that you see listed there. on page 31. And that's where our bead kind of looks like this. And so instead of having nice toes that are blended in, it kind of rolls over and you kind of got this space underneath the edges there. Again, that creates a weakness, and that's called overlap. And overlap is almost always going to be a defect. We just don't want overlap. It's a weak weld if it's overlap. And so most of the time you're going to need to redo that if you've got overlap in a weld. Now, what causes undercut and overlap? They're exactly the opposite of one another. So overlap, and you'll see listed there, is caused by too slow a travel speed, so you need to go a little bit faster, or the machine's too cold. So it's either too cold or too slow for overlap, just the opposite of undercutting, which is too fast or too hot. So when you see the overlap or see the undercut, now you know what to look for. Do I need to either speed up or slow down my travel speed? Do I need to either turn the machine up hotter or turn the machine down colder to cure that? But in either case, you want to fix it. You see spatter listed there as well. That's those little balls of metal that you see all around your weld beads. Some of that's unavoidable with stick welding and your wire feed processes, but we don't want too much of that. And as you see there, your arc length could be a problem. If you get too long an arc length, that's going to cause a lot more spatter to happen. You might want to lower the weld current. In other words, calm the machine down, turn it down to a bit of lower setting. But again, spatter, undercut, overlap, cracks, porosity, they're all discontinuities. It then becomes a matter of, is it bad enough to call it a defect or not, in which case it's rejected and we need to do it over or grind out the bad part and weld that part over. So we'll show you some real live examples of that when you get here in the classroom. You'll see actual pictures of it, and I think we're going to substitute a picture in the video here that might have some of that listed in there as well, but we'll see them real live here next week when you come to class.